Hello, this is my 8-bit binary adder, something I've been building over the past 2-3 weeks. The reason it took me that long was mainly because I didn't have all the bits when I started, uh, but I'll just walk you through it. So, I mean, this is actually quite easy to build because you can build it just with like a 1-bit adder, then a 2-bit adder, then a 3-bit adder. You can build it over time anyway, so you can test it all the way through. It doesn't have to be finished before it works. So yeah, each one of these, each side of one breadboard is a full adder built out of just AND gates. Sorry, NAND gates. I use this schematic. So that's a full adder using just NAND gate logic. So I done that on there and built my first one. And this is the carry in for that. So it's just grounded at the moment because it doesn't do anything for the time being. Yeah, so got 8 of those, one for each bit I want to add together. Here's my input, so we'll call this A and this B, and there are LEDs just to show you what's lit up there. Kind of pretty bad design putting all these cables here, but yeah, I'll do something with that later. And here's the output. So, yeah, so you can put the two numbers in here. This will add it together with each bit carrying over to the next one, and it will output it over there. So I'll turn it on, and we'll try something simple. We'll just do 1 here, 1 and 0, which, as you can see, is 1. So if we do 1 and 1, see orange and red there, that's the different colours for A and B. And you'll see over here, it's now 2. So we can do 1 and 3 if I can get in there. These switches are very small. So that's 1 and 3. Sorry, 1 and 2 in binary. Sorry, I get confused because these switches, they just have 1, 2, 3 on it. It gets kind of confusing. But yeah, this is 1 and 2, which on here is 1 and 2, which is 3. Right, so if I've done 2 and 2, as you can see, it would be 4. So here you have 1, 2, and 4. And if I just filled up one of them, like so, you'll see it's just output there. So this is 255. This is a full 8-bit. But if I added 1 to it, what it would do was carry through all of these and output just this last LED here, which would be 256. But all these would be off. So we'll do that. Look. Let's put 1 on there, and as you can see, so that's it, carrying the 1 all the way through there to get to 256. And you can, so this is 9-bit output. Usually you wouldn't see this last bit, or you wouldn't be able to use it if you was only expecting an 8-bit number. Yeah. I mean, that's about it. I can't really show off much else other than adding up different numbers. But I plan to actually do something else with this. As you can see, I've got quite a bit of space here. And I want to try and make this subtract numbers as well. That's relatively easy. I just need to invert all the inputs of this. And if I want to subtract, I'll have a little switch somewhere saying, subtract this instead of add it. And when it's subtracting, I need to invert all these inputs and add 1 here. So this carry can be the added 1. So if I want to subtract, that would be over here on 1 instead, and these will all be inverted. And that will subtract it. I'm not sure if I could fit that on here. I can move that over. I'm not sure if I could fit it on there because it requires quite a bit of... It requires XOR gates to do it easily. Yeah, so we'll have to wait and see. I can always just move these inputs to a different board and just have this for the inverting input. And just have these switches somewhere else. That might be the easiest way. Oh yeah, something else I forgot to mention. Because I was buying the bits I needed for this over time, I started using what I already had. And as you can see here, we've got these small focus please. We've got these small carbon film resistors, but when I ran out of them I had to fit to switch these metal film resistors, and then I ran out of them and had to get some different carbon film resistors. I actually prefer these carbon film resistors. They're the same size as these, because these ones, they're just really tiny. I'm not sure why. They're exactly the same capabilities, and yeah, I'm not sure why they're tiny, they're big when they're meant to be identical. Who knows? Just a manufacturer thing, I suppose. But yeah, I'll probably do another video. Actually, I'll turn that off because it gets quite hot with this many components. Yeah, so I'll try and get a subtractor working in here, and then I'll do another video on that. Thanks for watching, and see you later.